Okay, this is a bonus video for lab number 6. A bonus video for lab number 6. I think it's important to understand the VXLAN concept, so I'm going to write down here. Let's talk about VXLAN concepts. And the first concept is network virtualization overlay. So an overlay network extends layer 2 connectivity between server virtual machines in a tenant segment. So let's say that we have a building location A, and then we have building location B, for example. Okay, let's get rid of that. And then we have the two spines in location main data center, for example. Okay, so now that we have established, now that I have established where each multifunction switch sits at in this topology, the idea is to extend VLAN 102, which is layer 2, to extend it across layer 3. So let me draw our layer 3 routing domain for all these 4 multifunction switches that can do switching and routing. I think I went a little bit too high, so let's go here. So this is going to be a routing domain, and a routing domain is going to be using the BGP protocol, the BGP routing protocol for the underlay. And the idea, like I mentioned on the overview, and is worth repeating, is to stretch this VLAN 102 over layer 3 to location B. So in essence, what we're doing is that we're doing this. We're stretching this VLAN across over layer 3, over a layer 3 network. So let me use this color. So this is a layer 3 network. Okay. And over here we have the boundary for layer 3 up, right? Remember the overview? Layer 2 for the downstream devices, and this is the boundary for VTAP number 2, layer 3 up and layer 2 down to the devices. Okay, so far so good. So far I have covered this overlay network extends layer 2 connectivity between server virtual machines. So now that I explained that we're stretching this VLAN, that is a lot of it's a very packed sentence, and you're gonna see what I mean. So let's go ahead and extend VLAN 104 as well, as we unpack all this deep meaning in a single sentence. And the reason why I say that is because they also talk about virtual machines. That's why sometimes it's hard to read. You know, it's hard to read information because it's so packed that if you're not familiar with the technology, it might be a little bit intimidating. But what they're saying here is that they have, for example, nhost 1, nhost 2, nhost 3, and nhost 4. And what they're saying is that virtual machines, right, living on these servers, for example, let's say that we have 6 virtual machines per server, for example. Let's do that. VM, and let's draw another 6 virtual machines. And one thing I learned is that by not rushing the video and actually drawing it, I'll give you time to think and internalize what I'm saying and what I'm drawing. So hopefully you will make a connection. So that's it. We're extending the layer 2 over layer 3, and the medium that we're using is these overlay tunnels like BNI 104, which is related to BNI 1004 that is associated, so let's use a red color, that is associated with VLAN 104, right? Like in the overview video. And let's say that VLAN 102 is associated with VNI 1002, that I'm going to describe what that means. So let's go ahead for now, make this association that this VLAN is going to be related to this subway lane, like I mentioned on the overview. Imagine that this is like a BTAP1. Imagine that is a subway station, BTAP1, and the other subway station is BTAP2, and the red line is the subway train that will take you to, in this case, VLAN 104. So once you get to this station, you're gonna exit the BTAP, and then you're gonna take the exit 114, and then you're gonna get to the location that has that particular address, 192.168.104.11, for example. And the same thing for if you are in VLAN 102, you get into this bus station, the train station or subway station. You get into the purple line, for example, and then you take that train all the way to BTAP number 2, and then you're gonna, instead of exiting 114, you're gonna exit 111, and then you're gonna arrive to your destination 192.168.102.11, which is part of VLAN 102. So this is what they're saying about the network virtualization overlay. It's an overlay that is on top of this layer 3 network right here. So let me highlight it with yellow. So this is the underlay, and the overlay tunnels are VNI 1004 and 1002. So that is a lot of information on this little sentence right here. So let's continue. Over an underlay L3 IP network, and that's what I described already. So let's go ahead and check that. If I continue here, it says a tenant segment can be a group of hosts or servers that are spread across an underlay network. Another concept is that whenever you have a multifunction switch, so let's talk about spine 1, which is this one right here. Okay? So spine 1, if you look at the physical switch, it has a routing component, and it has a data plane component, right? Control plane as well. And normally it's just a single routing function per switch, per multifunction switch. But whenever you have a tenant segment, what it means is that if you employ what is called BRF, this DELL switch ships with a default BRF. And a BRF is a virtual routing and forwarding segment that will allow you to partition a switch into multiple switches with routing and switching in the same hardware. So you can have multiple routing tables that are isolated, and then you're gonna have isolated ports, right? So in this case, each DELL OS10 switch ships with a default BRF, virtual routing and forwarding. It is recommended that once you get the switch to create a management BRF and put that out-of-band management interface into this management BRF, as well as other ports that you are planning to use for management, for example. And then another thing that you can do is that for this VXLAN, EVPN, BGP fabric that is part of lab number 6, you can actually use, let's say that we're going to use this section in red, and this tenant segment. Let's call it BRF red, for example. So that's everything that we configure on this particular tenant segment BRF red is gonna encompass all these VXLAN, EVPN, BGP, and it's isolated from the other BRFs that you might have on the switch. And this is just an example. So let's see what else. As you can see, it's a lot of information packed in a few sentences. A tenant segment can be a group of hosts or servers that are spread across an underlay network, and that's what we're looking at here. We have our servers with VMs in one location, our servers and VMs in another location, and the idea is to create these overlay tunnels. So let's continue. What is the protocol that we use for these tunnels, right? It's called the Virtual Extensible Lan, VXLAN, Virtual Extensible Lan. So let's make a note here, VXLAN. So let's use the same color. Let's use this color right here. So I already talked about network virtualization, overlays, MBOs. And now we're gonna talk about VXLAN. So it's a type of network virtualization overlay that encapsulates a tenant payload into an IP user datagram protocol packets for transpose across the underlay network. So what happened here is that, let's say that nhost 1 is going to send a frame, and that frame gets to the BTAP, and on the BTAP it gets that frame and wrap it up on a VXLAN frame. So what is going to happen is that packet that you sent over is going to have another encapsulation, and it's going to be called the VXLAN. And then inside here you have your regular packet, your regular frame that has the destination IP address, the source MAC IP address, the what is it called, the source MAC and the destination MAC, and then you wrap it up into this VXLAN encapsulation, and then in the BTAP, in order to move it across one BTAP to the other, we're going to be using the underlay. That's why BGP is important. So now we add another encapsulation, right? And this encapsulation is going to be of the, let me see here, just to make sure I say it right, IP UDP. Okay, so let's highlight that. So it's going to be an UDP packet with an IP address with the source and destination where it needs to go. So the idea is to get out from this train station and go across, in this case, to spine 2, for example, then coming down into BTAP 2. And once you get to BTAP 2, what's going to happen is that you're going to remove this UDP because you don't need it anymore. Then the VXLAN is going to go into the BTAP to be part of the overlay BGP process, and then it's going to find out where you need to exit in order to reach the final destination. And once this packet of VXLAN get decapsulated, then with the IP address that is here for the destination, is going to reach 192.168.102.11. So that will take care of how this virtual extensible LAN protocol works. And basically what it does, it will encapsulate this packet that is sent from the host and make it suitable to be transported from the overlay to the underlay. And once it gets to BTAP number 2 on the underlay, then it gets to the overlay, and then the VXLAN information is going to be read. Then because of the EVPN process has all the addresses that each BTAP has, connected, then it's going to say, oh, okay, so the destination IP, once you encapsulate the VXLAN and you have the destination IP, then okay, you need to go, for example, to 192.168.102.11 if you want to reach this particular server, and if you need to reach the other one, then you should have gotten the red line, and then the address here should be 192.168.104.11. Just an example. So as you can see, there's a lot of information on these two terms right here. So let's go to the next one. Okay, so let's go to the next one. So the next one here is going to be called the VXLAN Network Identifier. So let's call it here VXLAN Network Identifier, or VNI, which is this one right here, VNI 1004 and VNI 1002. So this is the VXLAN Network Identifier. In this case, will allow us to associate VNI 104 to VLAN VNI 1004 to VLAN 104, and VNI 1002 it can be associated. It's going to be associated with VLAN 102. So that is the idea, to map not only the VLANs but also the overlay networks. The next concept is the concept called VXLAN tunnel endpoint, VTAP, and this is another component of this VXLAN EVPN BGP, right? So this VXLAN tunnel endpoint is basically VTAP1, for example, and so let's read what it says here. It says a switch with connected end hosts, which is going to be VTAP1 is a switch, right? And we have the VTAP process activated in leaf 1, and leaf 1 has connected two endpoints. In this case, we have end host 1 and end host 2. So that holds true there. And then the virtual networks map to VXLAN segments. Okay, so we have VXLAN segment VNI 1004 and VNI 1002, and as you can see, they map to each of the VTAPs. They don't have to. If you have 10 VTAPs, maybe you have 5 that are connected to VNI 1004. Maybe the other 10 are connected to VNI 1002. So it doesn't have to be each VNI doesn't have to connect to each VTAP. Let's see what else. Local and remote VTAPs perform encapsulation and decapsulation of VXLAN headers for the traffic between the end hosts. A VTAP is also known as Network Virtualization Edge. So this is what it does, right? You get the frame that is sent by the host. The VTAP receive it. It will wrap it up into a VXLAN frame, and then it's going to wrap it up into an UDP header and footer, and then it's going to send it over the underlay, so that way it can travel to, for example, spine 2, and then into VTAP 2. Once that UDP IP packet gets into leaf number 2 underlay, then it's gonna say, oh, okay, so you have a VXLAN header, you need to get into the overlay, and then once you get into the overlay, then you're gonna be into the BGP part of the EVPN routing, and then once you remove that encapsulation, that packet is gonna have an IP address, a destination IP address, and then it's gonna go to either VLAN 102 or 104. So that's what they're saying here with these VTAPs. One analogy that I mentioned on the Lab 6 overview is to imagine the VTAP 1 as a subway station, and in that subway station you have this red line and the purple line, and each line is gonna take you to different locations, to different parts of the city, for example. So what is the next concept is gonna be bridge domain. So let's continue. Let's do here bridge domain. And so basically this is an L2 domain that receives packets from member interfaces and forwards or flows them to other member interfaces on the destination MAC address of the packet. Take two. A bridge domain, a L2 domain that receives packets from member interfaces and forwards or flows them to other member interfaces based on the destination MAC address of the packet. OS 10 supports two types of bridge domains, a simple VLAN and a virtual network. So yeah, those are the two types of bridge domains. So in this case, if we look at, for example, at the boundary over here on the left for layer 2, layer 3, layer 2, and the boundary over here for layer 3 and layer 2. So if we look at layer 2 here, we're going to have what they're saying over here, simple VLAN, a bridge domain, a VLAN ID representing. So in this case, you have VLAN 102 and VLAN 104. So that is one type of bridge domain that we're using. The second bridge domain is a bridge domain which is a virtual network with a virtual network ID. A virtual network supports overlay encapsulation and maps with either a single VLAN ID in a switch scope VLAN, and so that is the example that we're doing on this lab. So I'm not gonna go into the other one, it's a little bit deeper. So let's keep it simple and not get in the weeds. So the next concept is called distributed routing. So let's go ahead and use orange. So all BTAPs in a virtual network perform inter-subnet routing and serve as a layer 3 gateways in two possible modes, asymmetric routing and symmetric routing. So the purpose of this lab is to talk about asymmetric routing. On the next lab is going to be symmetric. So let's stick to this one. All BTAPs can perform routing. Okay, routing decisions are made only on ingress BTAPs. Egress BTAPs perform bridging. So let's stop at that. And so the idea here is that all these routing and forwarding that is happening within the same company, the same domain, and if you have to connect to external routes like type 5 routes, then you're gonna need to use symmetric routing, in which all the BTAPs perform routing and the routing decisions are made on both the ingress and the egress BTAPs. So that is going to be the difference. So let's stick to this example right here for asymmetric for now, and once you get there, once we get to the next lab, I'll explain that part. So the next concept is virtual network. In OS 10, each layer 2 floating domain in the overlay network is represented as a virtual network. So yeah, so this is going to be our layer 2 floating domain in the overlay network. So that's going to be our virtual network, which is also an overlay network. It has a lot of terms. The next concept is called the virtual network identifier, which is a 16-bit ID that identifies a virtual network in OS 10. So in OS 10, we are using only 16 bits, which is plenty to identify these VNIs. So the next one is called the virtual network interface, a routed interface that connects a virtual network bridge to a tenant VRF routing instance. Okay, so let's go ahead and so a virtual network interface, a routed interface that connects a virtual network bridge to a tenant VRF routing instance. So like I mentioned previously on this BRF, let me highlight it with yellow. So on this switch, if you remember, when on the beginning of this video I mentioned that spine 1 can be partitioned into several BRFs, virtual routing and forwarding instances, in which each partition is going to have its own routing table, is going to have its own data plane, information logical, right? And then you're going to have a separation. It's like kind of doing VLANs on a switch, but in this case, instead of doing VLANs, we're partitioning actually the whole switch in order to have several routing tables that are isolated. For example, in this case, I mentioned that we're using the Tendon Segment BRF red, for example, and that's where we are doing all these connections for BGP for spine 1, and then for spine 2 it's going to be the same setup. You're going to have the same type of BRF partitions, and then we're going to be using BRF red, for example. The same thing for BTAP 1 and BTAP 2. We're going to be using this segment, one of the segments, and we're going to call it whatever we want. In this case, I'm just saying red because I'm looking at VLAN 104, but it can also be purple, so it doesn't matter. Let's see what else. Access ports. A port on a BTAP switch that connects to an end host and is part of the overlay network. So in this case, this an access port can be Ethernet 111 and leaf 1, Ethernet 114 on leaf 2, and because they are part of the virtual network, they are the access ports for this environment. Network port, a port on a BTAP switch that connects to the underlay network. Ethernet 113 on leaf 1, and then Ethernet 112 on leaf 1, for example. In leaf 2 is going to be the same. In this case, one port 112, and in this case it's going to be 113. And then for the spines, for this network port is connecting to the underlay network, is going to be 113 and 112, 113 and 112. So that's what they call a network port on this VXLAN environment. And then you have a switch scope VLAN, and let's see, a VLAN that is mapped to a virtual network VNID in OS 10. All member ports of the VLAN are automatically added to the virtual network. So these are some of the concepts. Okay, it says, well, let's continue. You can map only one VLAN ID to a virtual network. So that's what we're doing here. We're mapping VLAN 102 to VNI 1002, VLAN 104 to VNI 1004. Ideally suited for existing tenant VLANs that stretch over IP fabrics using VXLAN. So yeah, that's part of the lab. And I'm not going to go into port scope VLAN. That is a concept that doesn't come across often, and I haven't had a use for it. So once I get some time, I'm going to dive into it, but not right now. Let's keep on moving. And I guess that's it. That's the end of the VXLAN concepts. And as you can see, I found this on the DELL Smart Fabric OS 10 User Guide Release 10.5.3, and there is a lot of information packed. That's why when I was reading this document, I was like, okay, so I just couldn't wrap my brain around, like, what do they mean by that? But the thing is that I had to read the Cisco book for what is it called, VGP, for example, to understand all the concepts. Yeah, I had to read about VXLAN from other sources, and then on this particular guide also talks about the VXLAN, and so I'm using all kind of sources just to understand the concept and being able to explain it. But I'm gonna stop this video. It can go very long. And if you look at this guide, it's gonna give you all kind of information that you can try, and configure this type of network. But I think the lab is a whole lot simpler. It's just more, how to say this? It is just something quick that will show you how to do it, how to test it, how to use it. Now, if you wanna internalize it, yeah, I suggest to read the whole documentation and really, really understand it. All right, so that's it for this video. Thank you.